Hi and welcome back. This lecture is arguably one of the most important lectures of the entire course. That's because Python and Boto 3 rely heavily on traversing and parsing JSON data. And the reason for that is simple. When you query AWS using Python, along with the Boto 3 library, the metadata returned from AWS is in JSON format. That's why I highly recommend this lecture, even if you have a lot of experience with Python. If you haven't spent a lot of time traversing and parsing JSON documents, then you'll need to make sure you have a pretty good handle on this topic. With that stated, let's move on. If you don't know, JSON stands for JavaScript Object Notation, and it's mainly used to transfer data in machine-readable format for processing. Now, we're going to spend some time learning how to traverse and parse JSON documents. But to put things in context, I think it's important to illustrate how we get the JSON formatted metadata out of AWS in the first place. On the top here, you see a little piece of code. And don't worry too much about the details right now. We're going to cover this at great length later in the course. So for now, just feel free to follow along. As you can see on the top here, we've imported the Boto 3 library into our Python script. We've also imported a library called pprint, but we haven't imported the entire library. From pprint, we've imported just the class pprint. If this seems confusing, it's because pprint is the name of the module, but it also contains a class called pprint. Next, we tell Python what type of Boto 3 resource we wish to create, and we set that equal to a variable called S3C for S3 client, because our focus is going to be on S3 buckets from a given AWS account. We then set a variable called buckets, and using the S3 client that we created above, we chain a method to that called list_buckets. And what this does is collects a lot of metadata about the buckets in an AWS account, and it holds it all in a variable called buckets. Now on the line below, we've used pprint to print out buckets, and this just helps us format it a little bit better. We could simply use print, but you'd end up with a bunch of jumbled up text that looks like it was word wrapped, and that's not very easy to read. What you see below here will be the output of pprinting buckets. This is a little easier to read, but it's still a little busy. The good news is that JSON is so common, there are tons of tools for formatting. In fact, whichever IDE you use to code in probably has a package that handles formatting of JSON. But there are a lot of good web resources too. This is one that I like to use. It's a JSON formatter by curiousconcept.com. If you've downloaded the presentation, the link you see at the top here is clickable. Basically what you can do is copy the output data from the previous screen, or just a portion of it if you have a lot, and paste it into the text area here. On the right, you'll see some options for formatting. It lets you choose things like the number of spaces or tabs and a particular JSON specification. It even has a low-level option to correct certain errors that it finds. Let's take a look at the result of running the previous output to this formatter. As you can see now, the output is nicely spaced and a lot easier to read. You have your bucket variables at the top, along with the listing of each bucket in an AWS account. Additional metadata includes the creation date and the name of the bucket. So we've told you what JSON is and what it's used for. A few things we can say about JSON objects is they consist of key value pairs. And these key value pairs are separated by colons. And further, each set of key value pairs are enclosed within curly braces and separated by commas. Let's put this under the microscope for a second and take a closer look. So what you see here is the output that we were looking at on the previous slide, except that I've added some comments in green. And on the right, you'll see some general rules for parsing JSON objects. Let's analyze the output on the left a little more closely first. We want to see if what we said about JSON objects is true. We said that the objects themselves are wrapped in curly braces. If you look at the variable buckets here, it starts with a curly brace, and if you go down to the bottom, it ends with a curly brace. So that's an object. But what about everything afterwards? Well, we also said that JSON objects consist of key value pairs separated by colons. If you look here, we have a key of buckets with an uppercase B, and the value is an array, which Python calls lists, of all the buckets in an account. Now, if you drop down below that, you'll see curly braces again. So what's happening here? Well, these still meet the definition of objects. What you'll commonly hear people say is that these are nested objects. And that's one of the powerful features about JSON. You can nest objects inside one another. If you take a look at this curly brace, and the one that closes it, followed by a comma, you'll see that within it, you have two keys, the creation date and the name of the bucket. The value for the creation date, separated by a colon, is a timestamp. The value of the key name, separated by a colon, is the name of the bucket. And the third thing we said about JSON objects is that individual objects are separated by commas. So if you take a look again at the closing curly brace for this bucket, you'll see that a comma follows it. On the next line, you have an opening curly brace. Within that, you see another creation date and the name of another bucket. Now, if you plan on using Python and Boto 3 a lot, you're going to be writing a lot of code that looks like this. You can see here that print buckets, then buckets with a capital B, an index of 0, and the name will print to the console the name of the first bucket. But this is where a lot of people have trouble. So I'll put a couple of rules here to help you write out statements like the one we were just looking at. The good thing about these rules is that you can start at the beginning of a JSON object. And regardless of the number of nested objects, you can go back and forth between the rules until you've drilled down as far as you need to go. So now we've looked at both sides of the slide. Let's start back at the top on the left and refer to the rules on the right to see how we can traverse this object. Let's start with buckets. We use the list_buckets method to hold all of the buckets of an AWS account into one variable called buckets. As you can see on the right side of the equal sign, we start with a curly brace. So let's take a look at the rules for a second. Rule 1 is that if you have a curly brace that's followed by a string, use the string name. And that's what we've done for the example here. We're printing the buckets variable, but we're drilling down. So we start with buckets with a capital B. In this example, we have an index of 0 that follows. So let's take a look at the rules. In this case, rule 1 wouldn't apply. But taking a look at rule 2, we see that if you have a string followed by a square bracket, then you should use numbers for the subsequent sets of curly braces. And this is in fact what we see here. We have the string buckets with a capital B, with a colon and a square bracket. So to access anything between this opening square bracket and this closing square bracket, we need to use numbers for each set of curly braces. Going back to the example, we're trying to get information on the first bucket. Since lists in Python are basically like arrays, they're 0 indexed. So information about the first bucket, we would use the index of 0. And that'll represent this first set of curly braces. From the example here, we wish to get the name of the bucket. So how do we do that? Well, we've already started with the curly brace at the top. That was followed by a string. So we apply rule 1. Then we have a square bracket followed by a curly brace, to which we apply rule 2. In the example, we want to get the name of the first bucket. So how do we represent that? Well, we just use rule 2, and that doesn't apply going forward here. But if we go back to rule 1, we see that we have a curly brace. And after that curly brace, we have string names. We have two strings that represent the keys of the two pieces of metadata in this nested object. So we can use either one of these. If we want the creation date, we could put in square brackets here, creation date, but we want the name. So in square brackets and quotes, we'll use a key name of name. And if we print this to the console, it'll print the name of the bucket. And let me just say that metadata containing timestamps are probably one of the most difficult things that you'll have to traverse when dealing with Python and Boto 3. And the reason for that is because they contain a lot of commas. So in general, JSON formatters will really help out, but if they were smarter, so to speak. But what you would normally see is metadata presented as follows. You'd have your buckets variable, which is a JSON object, and within that, you'd have nested JSON objects representing all the buckets for a given AWS account. So here we've written this out as most metadata is written out when you're performing these types of operations. The creation date is a key that contains the value of a timestamp. Since each key value pair is separated by a comma, you see that on the next line, you have another key of name, followed by a colon with the value of the bucket name. And that's basically it. As stated, I know this can be a difficult topic for someone, especially if you haven't had experience dealing with JSON objects in the past. So if you have any questions, please leave them in the comments below, and I'll be sure to answer them as quickly as possible. When we come back, we'll learn how to work with date and time information in Python. So when you're ready, come on back and join us for the next lesson.